Morning, everybody. I just put another reminder into the Zoom chat about the polling questions for this week. So if you haven't already done so, I've tried to give you a few reminders in the chat to please go to the polling page that you can see, hopefully. I think should be able to see this. I guess if someone just wants to confirm quickly that you can see my screen, for some reason the little border that's usually around it when it's screen sharing is not there, but okay, I see some thumbs up and things. Okay, so yes, thanks. I will try to hide these meeting controls just so they're out of the way so I can see my tabs up here, which is handy. But yeah, please go and visit the polling page, fill in your experiences from week 2, share your comments or your thoughts there. We have 3 questions this week. So the first is basically just a review question that we will ask every week, and that is, what did you learn during week 2? And you can both fill in responses here and vote for things that you've already seen filled in. There's some question here about how it's going with Git. We realize this is a new thing to be working with, and sometimes it goes smoothly, sometimes it's a bit challenging, but we'll talk about that. It's very typical to be a little confused. So I see one, I'm a little bit confused comment at this point. And then some other questions or thoughts about the pair programming. So please, if you haven't already, fill in your comments there. And I will just once more, once more go and copy and paste the link in the chat. So there it is in the chat one more time. So you're welcome to continue to fill things in there. While you do that, we can start looking through some of the responses we've already had here. So I'll just switch over to this mode for the moment. And what we can see for week 2 is that we learned how to create and modify lists, use indices, so to use index values to refer to items in a list. That is something that was a big focal point for week number 2, so that's good to see that did come through. I'm also pleased to see F strings listed here. So we will see F strings more and more frequently throughout the course. We are making an effort to try to use F strings wherever we can when there are print statements and things like that, just to help you get used to seeing them, using them, and understanding how they work, because they are such a convenient way to format text in Python. So you'll see F strings, for example, in this week's exercise in a few different places. And I don't believe you're asked to use them necessarily in this week's exercise, but just you should be aware that you will see them. And if you're confused about F strings, please let us know in the chat or in Slack. We also learned a little bit about using Git, the basics of Git. I think the biggest jump that we made last week was to go from dragging and dropping files to github.com to actually using Git to stage files and to commit changes and then push those changes to GitHub, and also to pull things down from GitHub. So we'll continue doing that throughout the rest of the course as well, which is, if you're a bit confused or frustrated with Git at the moment, don't worry, that will get better with experience. So this is, I think, very typical list for what we've seen in week number 2. We jump to our second question here about how it's going with Git. For some reason, it wants to be way down at the bottom. Looks like overall, very quickly looking through this, we're pretty much about where we would expect you guys to be now. Some people are feeling pretty good about it, others a bit confused. I think this is something that just interacting with the files and the system for how you make changes and save them to github.com with Git gets, I don't know, it's not it's not automatic. It's not necessarily intuitive right away, but once you do it a few times, it becomes very smooth. And it's like for those of us who've been doing this for years now, I don't even think about it. It's just such a natural thing to stage, commit, push, and it becomes easier with time. So, and I think, if you do need more practice with Git, the good thing is that we're going to continue to work with Git throughout that. So I know there are some people who are having issues with cloning the wrong notebook and things like that. Maybe we'll come back to that in just a moment. Håvard can review how to clone the exercise notebooks. But if you are having issues, it's important maybe just to let us know in Slack or in the Zoom chat so that we can try to help people, because this is an essential thing for saving your work for the exercises. So it's good that you don't just sort of get stuck and feel like there's nothing you can do to move forward. But overall, having issues pushing, pulling, we'll come back to that. Pushing from Jupyter Lab to GitHub doesn't work for some reason. It's possible there are a few different things that could go wrong there, and I think Håvard will review those in just a moment, so we'll come back to that as well. Going well, not sure Git remembers my credentials when I start next session. So we have updated the course page information on using your personal access token with Git. So I will maybe just very quickly go here to the course page. So we had our Meet Git lesson last week in lesson number 2. And if we scroll down a ways here, after creating this personal access token, I believe we had a place to cache it, which is apparently quite far down. Here we go. So there was this note toward the end of the lesson, or the end of this part of the lesson, where you could basically save your GitHub user token in memory in the Jupyter notebook system from the CSC, for example, so that each time you want to use Git in the future, it would remember your personal access token and you wouldn't have to type that in or copy paste it again. This line here has changed slightly from the version when we gave the exercise. So we have modified things now so that the file is stored in a place that should be retained each time you connect to the CSC notebooks, and that should hopefully resolve the issue of having to put in your token a second time. So just be aware that if you look at the Meet Git lesson down to the part about caching your credentials, that it has been updated to work in a way that should now provide you with an easy way to have your personal access token stored each time in the CSC notebooks. But let's take one look here at the last question about the pair programming. So, and I guess this is kind of pair programming and anything else. Felt so much easier to complete the task with a pair since you could discuss about how to do it. That's great. That's really ideal for what we were hoping with this kind of pair programming exercise, is that it's nice to have someone who you're sort of dedicated to work with, and you can discuss things, you can work through things, and you can overcome issues that you might be stuck with by yourself. So that's really nice to see. Bit slow, maybe nice to have someone to review the code afterwards. Yeah, I mean, of course you'll get feedback from us. And the assistants in the course will review the exercises and give you feedback about your code. But of course, that's after you submit it. So it's maybe you would like to have someone look at it before it gets submitted. I do understand that. But yeah, I mean, the pair programming is a trade-off. When you have to coordinate with someone else to do things, of course, that does make it a little bit more challenging. But overall, yeah, it'd be faster to work alone, but having another person to ask for help is great. I think that pretty much summarizes it right here. It could be faster to work alone. Depends on where you are. If you're a brand new programmer, maybe it's faster to work with someone else. If you're experienced, then it might be a bit faster to work alone. But that's a good summary of how I think a number of people feel about the pair programming. And we encourage it for the course, just because if you are brand new, it's very helpful. Otherwise, is there going to be some kind of model answer how exercises should be done? I think not necessarily. In the future, though, we do have the possibility, if you have questions specifically about the exercise, it's always possible to ask us in Slack or to ask in the work sessions for the exercises, to have one of the course assistants explain how to do one of the problems or something like that. We don't really share the solutions, in part because we tend to use similar problems every year in the course, and it would be preferable for us to not widely distribute the solutions. But individually, we're happy to explain how some of the problems are expected to be answered. Someone was surprised to like it. That's also a nice thing to see. And possible to go through the picture adding exercise. Otherwise, not possible to learn anything. Yes. I think we could give a demonstration of how to add a picture. It's maybe something that would be good to save to the end of the time, but if someone is interested in knowing how to add a picture in Markdown, there are some easy ways to do it. But if you're wanting to upload your own picture to GitHub and refer to that, it does require a few minutes to demonstrate. So if there is interest at the end of the time today, I would be happy to demonstrate how to do that, or we can perhaps come back to it. So please try to remember if you're interested in this picture adding exercise, because I think we could do it, but it might be good to save it to the end in case we run low on time. I think that's basically everything. I see one more comment here about the Git question about if there's no model answer that's provided, is it possible to have some tips about how to solve the problem? Of course, that's possible. That's the point, in some sense, of these work sessions, is to come and ask questions about the exercise to get some help from the course assistants. And in that sense, if you're looking for some guidance on how to answer the problems, you're always welcome to go there, or you're also welcome to ask us in Slack for some help with how to solve a certain problem. That will become perhaps more common in the later exercises in the course. But please do ask questions if you're uncertain about how to proceed with one of the problems. And if it's an exercise you've already completed and you want to know, why something didn't get full points or how you were supposed to have done something, again, please feel free to ask myself or Hovard or either of the course assistants for some additional guidance. So thanks for the input on the polling this morning. It's very good to see kind of some picture of where you guys are at. It's a bit harder to be as informed as normal when we're not meeting in the same classroom. So this is very good to see. And I think I had a couple other notes maybe before we move on. One of them was there are some enrollment issues, and we're aware of these. If you're having problems with enrollment and you haven't already made it clear to us, please use the enrollment issues Slack channel to make sure that we know that you're having a problem with enrolling to the course. There are, I think, at least 2 students right now who are having problems, but there may still be others. And it's enrollment issues, enrollment-issues in Slack. So I just put it in the Zoom chat. If you're having problems, please let us know there as soon as possible so that we can try to find a way to make sure that you can receive credit for the course. Ultimately, you will, if you do the exercises and you participate in the course, we'll find a way to make sure that you're registered, but it's just helpful for us to know how many people are having problems at the moment. I think the other thing was related to cloning the exercise repositories, and I guess maybe Hovard was going to show something about that. So I will stop sharing my screen for the moment.
Yeah, great. I can just briefly go over how how you can make sure that you're cloning the right repository when you're solving the exercises. So on our course pages, on the exercise page for each week, there is a link where you can accept the GitHub Classroom assignment. So when you click on that, it takes you to GitHub. It asks you to accept that assignment. So when we do that, it will create the repository for you. And that might just take a few minutes, but what you want to do is to make sure that you have created your own version by accepting that repository. So when I refreshed here, we can see it has been created, and clicking on that link takes me to my own version of the repository. So make sure that the repository has your username in the name of the repository, and when you click on here on code to get the URL that you are cloning, my username is also here. So that is the link that you copy and go over to Jupyter Lab, and inside of the exercises folder, you clone the repository with that link here. So that is kind of the way to clone the right repository. And then since we're doing some automatic grading and evaluation of your repositories, it's important that you use the files that are here for the notebooks. Don't change the names. Don't create new notebook files. Just use these and edit them with your solutions and answers to the problems, and then save that and upload those to GitHub again. And I can just I saw there were some questions about how to make sure that the changes are saved on GitHub as well. So if we make a change to a file, here I just delete something, and then in the GitHub plugin, I am in the repository. My file has been changed. I want to stage that to upload it by pressing the plus button. When I down here add a description of the changes I've made, I just write first changes here, and when I commit that and add my name, that comment that I put there, the description, first changes. When I go back to GitHub, back into my repository, and refresh that page, you would also see if it's pushed, it should refresh.
I think you committed but didn't push yet.
That's true. You have to remember to push. Very good notion. So pressing the up button here, push, I get a successfully pushed down in the right corner. And then the commit comes up here. So then I can see that the changes that I made were both committed and pushed to the GitHub repository. Yeah. So, and as you are working in pairs, it's important that you talk to your partner and make sure that you are, talk about how you want to solve the problems, and then either if you can meet up physically and talk, or have a Zoom meeting and share screen and show what you're doing and talk about the problems, then that is good. And make sure that you find out who is the navigator and who is the driver for this week, and who then pushes the changes to GitHub in their repository. Yeah, but the main takeaway is accept the assignment in in GitHub Classroom and use the link or the repo with your username in it. Yeah. And then we've seen there have been some people who have had some issues in the Jupyter lab with not getting where the plugin only shows a work repository and you're not able to clone any different repositories. If you're having those kind of issues, just message me in Slack and then I'll take a look at that with you. Yeah, so we should be able to solve that. Okay, I think that's it for now.
Okay, yeah, thanks, Håvard. And I will return to sharing my screen here. So just to remind you of a couple things, it's a little bit easy in a sense to save your changes when you commit things in Git and forget then to push them to GitHub. So if you want to try to remember, it is essentially like a 3-step process when you want to save your changes. Sorry. So you want to first stage the files that you want to commit. So basically the files that you have modified that you want to save with this commit change you're going to make, then you commit them. And then the important third step is to then push them to github.com. If you forget to push, it's not the end of the world because you can always go back into the CSC notebooks later and push the files at some later point. But of course, if you miss the exercise deadline because you committed the files locally and didn't push them, then that's maybe not so desirable. And if that does happen, it's understandable. Just please let us know. But yeah, are there any questions at this point about Git things or otherwise? Try to make my participant list and chat visible again here. Hide this meeting controls. Okay. If there are any other questions, of course, you can always put them into the Zoom chat as we get started here. But if not, I think we'll jump here to our lesson overview for this week. So we're on to lesson number 3. And our main 2 tasks this week are to learn a little bit about how to repeat things in a script by using something called a loop. And for those of you who have done any kind of programming previously in other programming languages, you'll probably be familiar with the idea of a loop. But essentially it allows us to repeat a section of code several times over. And the other major thing that we're going to cover this week are called conditional statements. And these are basically ways to make decisions in a program about what to do. So if a certain condition is met, you do one thing. If not, you might do something else. And we'll learn about both of those this week. By the end, we're hoping that you understand what a for loop is in Python. And I think that should be the case. And also how to use these conditional statements like if, elif, which stands for else, if, and else. And so we'll come to those as we go through the lesson for today. Like the last couple weeks, we're going to be working on our lessons in the form of a notebook. So I'm going to go here now to the CSC notebooks and I apparently did not log in. So I will do that. And then I'll create my instance here. There we are. All right, so we are in now CSC notebooks. Hopefully you are already at this stage. I'm going to go into the notebooks L3 folder for lesson 3. And our first lesson, or the first part of our lesson today, is going to be on for loops. So we'll go there to the for loops lesson. So the basic idea, as already mentioned, is that this is one way in which we can repeat a part of a code a certain number of times. And to get started, we can start with a bad example using lists like we saw last week in our Python lists lesson. So here we have a list of European cities. It should already be filled in for you. So you can just do Shift-Enter to run this cell and store the list of 4 European cities in memory. And if you wanted to, for instance, print out each one of these cities, we could go one by one and do a print European cities. And now we're going to give an index value to do this one by one. So we'll start with the first one at index 0, as you might remember. And then we can go like this, shift enter to run this cell. And when we print it out, we of course see Helsinki as the first city that is in our list of European cities. Now, if I copy this and just paste it into the cell underneath, I can change the index value to go to the second one and print out Paris in that case. Go to the third to get Barcelona. And finally, we can get Uppsala for city number 4 in our list of European cities. Now, probably you're already seeing why this is a bad example. Okay, first off, it doesn't scale very nicely. So if you have to copy paste and change this every single time, if you have a list of 100 cities, this is already becoming quite a painful task. But secondly, and actually maybe I'll make this a little bit bigger. I don't know if this will help, but make that a little bit bigger. Secondly, it's kind of designed to work right now for a list of cities that is 4 cities long. So if we copy these same lines, like let's update our list of European cities here to be 3 different cities in Europe. And if I just copy the text that we had from before and paste it here, of course, we can start with city 0 in our index value 0, and it's Riga. And then this city at position 1 in this case, at the second value in our list, at index 1 is Rome. And then finally here is Athens. If we try to continue now with the same thing we used previously, of course, now when I try to look for the 4th city, it doesn't exist, and I get an index error as a result, because there's 3 items in the list. I've tried to access item number 4, and naturally Python raises this index error to show us what the problem is with what we've just tried to do. So again, the problem here in a sense is that you have a situation where you're copy pasting things, and if you want to reuse the same sort of set of copy pasted lines for a different list of cities, it's possibly going to be a problem. So that's our motivation to introduce something called a for loop. Now, what we can do in this case is we'll go back to a list of 4 more European cities, but this time we're going to use a for loop to print out each of the cities instead of the approach that we had used previously. The way that we can do this is starting with the for statement, so FOR, and we'll say for city in European cities. And we'll explain the syntax here in just a moment, but we'll just type it in like this for right now. I'm going to press enter, and you should notice if you're typing this in as well that you press enter and you'll see that you're now indented underneath here. Print city. So this should be the format of the for loop that we'll use in this case. For city in European cities, colon, and then underneath it is indented text that says print city. If you run this cell, you now see Amsterdam, Brussels, Lisbon, and Reykjavik are 4 cities from our European cities list. That's convenient. We have now printed out all 4 cities with a sort of 2-line statement instead of copy pasting the same line 4 times over. But in addition, if we wanted to modify things to say, like, let's add a list here of US cities, and we'll say that's equal to, and I'm just going to copy paste this. So copy the list of cities there. So now we have our 1, 2, 3, 4, 5, 6, looks like 8 US cities. And following the same example that we had above, we can define our list of cities, and then I'll just copy this from above, copy that and paste it, and I'll change here this list that we're going to look at to be US cities. So we define US cities to be these 8. for city in US cities, print city. And now if I run this, what you can see is that we got all 8 of the cities written out. The advantage here in a sense is it doesn't matter how long the list is. So as long as the list has at least one item in it, this should work. And if the list has 1,000 cities in it, it should be no problem. It's the same code because all it's doing is going through this list of items and printing them out one by one. So you have some sense perhaps now of why this is useful, okay? One of the things that's a topic we will mention in the course and maybe come back to a few times during the course is the idea that we want to try to not repeat code if possible in our Python programs and in our Jupyter notebooks. If you can have one statement that redoes the same calculation several times over in a single line, that's much better than having to copy and paste that line 20 times or whatever the case might be. So that's our basic idea of how the for loops are working. I'm going to leave this, hopefully, try to leave this visible while we explain what the syntax looks like for how you format a for loop. The basic form looks like something like this that's shown below here. So it always starts with the for statement, FOR. Then there's going to be some variable name. And this is the variable name that's going to be defined and used during the kind of iteration in your for loop. And it'll be variable name and then the word in. And then there should be some kind of collection here. We've been using Python lists, but this could be other things. It could be, as we'll see later on in the course, it could be something like a series from the pandas library, or it could be a NumPy array, or it could be any other kind of collection of values that are defined in a variable in Python. But this should be, for us, for the moment, this will basically be Python lists. So for variable in collection, where collection is a list, and then this is going to be some set of instructions to do something with the variable. So this is not the syntax here necessarily. You don't type do things with variable, but rather that what you're going to do is everything that is underneath here that's indented is the set of instructions or the set of things that should be done for each one of the values in the collection that you have there. So spelled out a little bit more clearly, you can see things broken down here. So the variable is basically any variable name that you like. Oops. So, this is something you're free to choose as long as it's a valid Python variable name. Like, you can't use certain things. You couldn't say for in collection. That's not allowed, but basically any other variable name should be okay. Always starts with a for statement and ends with a colon. So this is what you can see at the end of the line there. And then the things that should happen are going to be indented underneath the for statement. So all of the actions or all of the items that should occur, all of the steps in your processing for each item in your list should be listed then beneath here. And there could be multiple lines, of course. As long as they're all indented, they will be part of this for loop. And there's nothing you need to do to stop the loop in terms of indicating that the loop is finished. There's no kind of like end for statement or something like that. All you do is just go back to the regular indentation at that point, and Python will understand that's the end of the for loop. So that's the basic syntax. In terms of thinking about for loops, I think you'll pretty quickly get the idea of how these are working, but there's a couple examples that we could look at. There's the sort of life of a cat that might be essentially the same thing repeated every day, waking up at a certain time, taking a nap, begging for food, taking another nap, resting, sleeping, going crazy, stretching, relaxing, more sleeping, and then going crazy trying to battle some goblin in the middle of the night. So anybody who's lived with a cat probably knows some form of the cat's life in something like this. But also for our daily lives, the situation might be somewhat similar. I would guess that most of us have a somewhat regular set of things we do every day. So we could imagine making a for loop that looks something like this, that for day in my life, where this my life variable would be a collection of all of the days of your life. you're going to hopefully wake up. I suppose this for loop ends when your life is no longer a valid variable, but you'd wake up, might take a shower, eat breakfast, brush your teeth, blah, blah, blah. These set of steps that you do every day essentially are like your daily life for loop. So the set of actions that you repeat every day is essentially filling in the list of steps that you execute every time you pass through this for loop. Every time the sun comes up, you do the same or similar set of actions. Hopefully not, we don't want to have the sort of experience of life that every single one of these actions is the same every day, because that's not going to make for a very stimulating life. But certain things, people need to eat, people need to kind of take care of themselves. So these steps may be repeating regularly every day. So just like when we thought about Bill, the brilliantly crafted vending machine from last week's lesson, when you think about Python lists and index values, you can think about Bill. When you think about for loops, you can think about this kind of daily set of steps you would follow. And that might be a handy way to try to remember how for loops are working. So to explore a few other things here about for loops, we can look now at another example. So here we have a list of weather conditions. So you can see we have rain, sleet, snow, freezing fog, sunny, cloudy, and ice pellets, the dreaded ice pellets. So these are possible weather conditions. I suppose we're getting closer to the ice pellets and freezing fog situation each day now. So just run this list, run this cell to save that list to memory. And we can, again, use a for loop if we wanted to print out the values that we have here. So for, let's say for weather, in weather conditions, colon. So again, starting with a for statement, then we have some variable here that we're going to define called weather, and then in, and then here we have our collection. And we're just going to print out the values. Nothing new here compared to the examples we have just looked at. If you run this cell, of course, we print out all of our different weather conditions. The thing that we want to show here is that if you then were to print out something like after the loop has completed, weather is, and you know what? Let's do it with an F string. So I'm going to make this an F string by adding an F at the beginning here. And so then we have our string of text. And so after the loop has completed, weather is weather. So what this should do is fill in the variable value for the variable weather in our statement when we run this line. After the loop has completed, weather is ice pellets. So what you can see is that this is basically just a regular variable. The variable that we define in the for loop has values that are one by one from our list assigned to it. And after the loop has finished running, we still have the last value from our for loop stored in memory in the variable weather. This is something to be aware of because occasionally you may reuse the variable name that is listed here, for instance, weather. You might reuse that sometime later in a program or a Python, a Jupyter notebook or whatever that you have created. And you need to be aware that it does still keep the old value from the last time you ran your for loop, for example, and sometimes you'll get unexpected behavior if you're using a variable that you might think had some other value assigned to it that was used at some point in a for loop. So just be aware that this is a normal variable and it will keep in memory whatever the last value was that was assigned to it. All right. And yeah, hopefully you're okay with this F string syntax. I think what we'll do is we'll just try to be consistent and use it and use it and use it so that you get more and more comfortable with this over time. I have very little ability to tell whether there are any questions, but I suppose if there are, you can always kind of like raise your hand in the participants list, or you can put something into the Zoom chat. If I don't hear anything, everybody's got their screens, like cameras off, so I'm kind of left then to assume that everything is okay. I'm not totally like thrilled with that, but that is the reality, I think, for what we're looking at right now. We'll have a check your understanding opportunity in just a moment, so maybe that's a good place to find out how things are going. But before we get there, we can talk about another thing that we could use with the for loop called the range function. Range function is a built-in Python function that's very useful for producing lists of numbers. So if we just want to see how it works here, we can use a for loop to do that. So we can say for value in range, and then the range function expects some number to be given here. So we'll say for value in range 5. And in keeping with our exciting way of learning about for loops, we're just going to print out value. So for value in range 5. So range 5 is a function, but it's going to return something in the form of a collection so that we can iterate through those values. And we're going to print them out. And what you see here is when you print out value, it's 0, then 1, 2, 3, 4. The range function gives us a list of 5 numbers starting at 0. So whatever number you put in here, you'll get that many values back from the range function. And if you give nothing else, it will start at 0 and it will go up by 1 in the case that follows like this. Important thing to note here is that you might think that when you give range 5, the last value you're going to get would be 5. But of course, because the indexing starts at 0, the last value you get is always whatever the number is here minus 1. So be careful with that. If you want to know a little bit more about what you can do with the range function, you can certainly do more than just get a list of numbers like in this format. We haven't seen this functionality before, but you can do something like help in a Jupyter notebook, help range. So this will use the built-in help. And then here you can provide some name of a function or a statement. And if you run this, you get the documentation about how to use the range function. So what you can see, for instance, here is you're going to get a range object. So we haven't talked really too much about what objects are here, but essentially this is going to be our collection of values. So if you give something with the range, it does appear you can give more than a single value in your range function call. So you could have a starting number, a stopping number, and even a step, which is the sort of how big of an increment between the values in your range function should you use in the case here. So this is what allows you to perhaps produce numbers that aren't going up by 1, but by some other increment. And then start and stop allows you to define what number you might start from and where you're going to stop in your range function. So that's handy. You can look up this help on any other thing. If we wanted to look up help print, for example, I could look up the print function, see how that's working. One thing that's kind of nice here is that by default, it will have the end of the line character be a new line. So every time when you print something out with the print statement, it has an end of a line character as a new line, which basically makes it work in such a way that it breaks the line. But you could define something at the end to be different than a new line. Could be a tab, and then you could have your values tabbed apart when you're using the print statement instead of having them on separate lines or whatever. So help is handy. We'll go back to looking at help range here just for a moment. And hopefully you have this help range up, because this is going to be useful in the check your understanding opportunity that we have here. So we have a program that will go through values for I in range, blah, 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 print I. What you want to do is figure out what values you should put into this range function in order to produce the following output, 2, 5, 8. Once you have figured out what to put in there, you can go here to the polling page and you can answer our question related to this. And I will check. It looks like, yep, Hovard's on top of things. So we should have it here. Here are the different options. I'll put it like this for the moment so you can see the question. So which values of the range function would produce the desired output? Again, the desired output in this case is to have, where are we here? 2, 5, 8. So please fill in your responses to the polling question, and we will continue in just a moment. So we have no one so far voting 092, 1 vote for 283, no one for 081, and then the remainder of the group voting for 293. So, oh, and there's 292 hiding down there below. Sorry, missed that one. So yeah, out of the options, it does seem there's a very clear majority. So let's have a look. We jump here to the notebook again. What we wanted to do was have a for loop that says for I in range, and then some numbers, and then print I. So the question is essentially, what do we put in here? And if we scroll back up for a second to the help on the range function, you can see that the starting number or start value here is going to be the first number. So sure enough, we want to have 2, 5, 8. Then this first number should be a 2, not a 0. So that makes some sense. The stopping number, as you see in this example here, when our stop number was 5 previously, we had 0, 1, 2, 3, 4. So we ended up with one less than stop. So what that means here is that we want to stop at 8. So our number should then be 1 more than 8. So it should be 2, 9. And then the step between the values, between 2, 5, and 8, they're going up by 3. So that's our step 3 in this case. So 2, 9, 3 would be my guess based on that. And if we go 2, 9, 3 here and run this, sure enough, we get 2, 5, 8 printed out to the screen. So of the options that we had here, 293 was in fact the correct one. So well done if you ended up on that as your conclusion for what to write there. As it turns out, there is no additional option for this, but it would be the same output if we did 210.3 in this case, because it's going up by 3. And I think we could even get away with 211.3 and still get the same output. This ending value, it's basically going to start at 2, go up by 3. So 2 plus 3 gives us 5. 5 plus 3 gives us 8. And then 8 plus 3 would give us 11. But again, because this stop value is here 11 itself, and it would need to be 12 in order to have the value of 11 printed out to the screen, you can see that in this case, because the change that we've made from the original value of 9 to 10 or 11 is still smaller than a next increment of 3, we would get the same output that way. So if I bump this up to 12, then we would add the number 11 here, because now we've added 3 to our previous value, and this is 1 bigger than the thing that's being printed out there. So hopefully I've not confused you with that, but just be aware that there are multiple solutions that would allow you to print 258 out to the screen using the range function. Okay, a couple other things here about the for loops. So another thing we can do here is we can loop over the length of a list using index values. What does that mean? Well, we've already seen that we can figure out how many items are in a collection using the len function. And now we've seen that we can use the range function to go through and to do something a certain number of times. So if range 5 allows us to print out 5 different numbers, it could be other things that we do 5 times, for instance, with the range function. And what we can do is we can combine these two to have one sort of fairly powerful thing that we can do in a Python for loop. So here I've got a list of numbers, just creatively called numbers, and we run that cell, store it in memory, and now we're going to use a for loop. And the task here is we want to print out the value of I and print out the value of numbers at position I within the for loop. So let's start with that part. So we have for I in, and in this case, we're going to combine our numbers list with the range function and the len function. So we want to go through and do something for each one of the numbers. So we want to do something len numbers times, because len numbers is going to be 4. We want to do this calculation 4 times. Now, what we're going to add in here is that we're going to wrap this in the range function. So we're going to use the range function to create our list of values that is the same length as len numbers. So in this case, 4. So this is basically like saying for I in range 4. Okay. And we're asked here in this example to print out the value of numbers. And there's also something else that's happening in here that's suggested we go over the loop of numbers and add the value of the for loop variable I to each value. So let's first start with just printing out our 2 things. So we can print out, let's do it with an F string again, because why not? So I is, and then we'll put in our variable I, and then we'll say numbers of I, oops, wrong brackets. Numbers of I is, and then we'll put this in here as numbers of I. So what this is going to do is going to go through here for each time, print out that I is, and then it should be the value of the variable I, and numbers of I is the value at index I in the list numbers. Let's just run that to start. And yeah, of course, I've got to kind of add my other close parentheses here, otherwise I get the syntax error. So try to run that, and we get I is 0. First time through our for loop, the value of I is 0, just because the range function, again, by default, if you give it just a single value in there, will create a list of numbers starting at 0. Numbers of I is 5. That is the value at position 0 in this numbers list. Next time through, we get I is equal to 1, and numbers of I is equal to 6. So the value at index 1 is 6 in our numbers list. And then we get I is 2, and numbers of I is 7, I is 3, numbers of I, or numbers at position I is 8. So that's printing out the values. And what we are asked to do is to go through our loop and actually add, in this example, the value of I to the number that's already there. So let's do it like this. Let's add a before to our text here. And then what we'll do is we'll say numbers of I is equal to numbers of I plus I. So we're going to take our list of numbers here, we're going to modify it each time we pass through this for loop by adding whatever the value of I is to the number that was stored there previously. Let's copy this line here and paste it underneath. So we have a before and then after. So before I is I and numbers of I is this. Then we do something where we modify the values at numbers of at position I, and then we can print it out again after we have modified numbers of I. Let's see what the output looks like this time. And you know what? I'm just going to make it a little easier to read, I'm going to add an extra print statement down here at the bottom just to give us an extra blank line between each one of these. So if I run this, what I see is before I equals 0, numbers of I is 5. After I equals 0, numbers of I is 5. Nothing happens because we added 0 to the value of numbers of I when we ran this line here. Not the most interesting case. If we consider the next iteration through the for loop, we see I is equal to 1. Numbers of i's is 6. So that's the value at position 1 in the numbers list. That's before. And then after, I is still equal to 1. Okay, I hasn't changed. We haven't modified that with our thing here. But numbers of I is now 1 larger than it was previously. So numbers of I is now equal to 7 because at position 2 in our numbers list, we've added the value of I, which is equal to 1, to the existing value that's there. And similarly, when you go to I equals 2, you add 2 to the previous value. I equals 3, you add 3 to the previous value, such that after all of this, if we print out numbers, we then see 5, 7, 9, 11. So we started out with 5, 6, 7, 8, and we've added 0, 1, 2, and 3 to the previous values there. This is just sort of a silly example in a sense, but it does demonstrate how you can use this range of length numbers functionality to be able to go through something and do some calculation a certain number of times. If you're confused about this, you can find a little bit more of a description of what happens in the text that is on in the notebook. And just as a note here, we've used the variable I here. When we're iterating through lists, it's very common to use I as the kind of iteration variable. It's very short and easy to type in. But you might see also J or K depending on the code that you're looking at. But those are very common. Why would you want to do what we just showed you how to do? Well, we have a simple example for that here. We have 2 lists in this case, a list of cities in Europe and a list of countries where those cities are the capital of that country. So, of course, Helsinki in Finland, Stockholm in Sweden, Oslo in Norway, Reykjavik in Iceland, and Copenhagen in Denmark. We're being very Nordic in this example. Let's run both of these cells. We can store these 2 lists in memory. And then what we want to do is print out each pair of the cities using a single for loop. And this is really the reason why it's useful to do what we just did with this for range len kind of construct. So what we can do here is we can say for I in range of length of, let's pick cities. So we're going to now get length of cities is 1, 2, 3, 4, 5. We'll get a range of numbers starting at 0 and going to 4 as our value that's going to be assigned to I. And then we can print out, and we're going to F string it again because why not? And we'll say that cities of I, so we'll take an individual value out of our cities list, is the capital, oops, I need to stay inside my quotation marks, of, and then we can put in here countries. Again, at position I. So the variable value at position I in the cities list will get filled in here is the capital of, and then the same kind of thing happens for the countries list here. So what we would expect to see is something like Helsinki is the capital of Finland. If we run this, then what we do indeed see is Helsinki is the capital of Finland, Stockholm is the capital of Sweden, blah, blah, blah. Okay, so the benefit here is we have 2 lists that are the same length that we want to do things with together. We want to take values out of both lists, and we want to take things from the same position in both lists and interact with them. This is actually a fairly common thing to do when you have lists of values. Maybe you have latitude and longitude that are both in lists for locations, and you want to sort of print them out together or somehow combine them in some other way. This is a pretty typical type of thing you want to do with multiple lists. And there are other ways to do it. There's a function called enumerate that can help with this. But what we're trying to demonstrate here is how you can take values from the same position in 2 lists that are related to one another and interact with them both at the same time. And one of the easiest ways to do that is to do something like this, where you use the range function to go through the index values of each one of the items in the list. We have done for I in range len cities, but we could just as easily put in countries here. The length of countries is 5, the length of cities is 5, and this won't change the output at all if you change the variable value here. Similarly, it's not a recommended thing to do, but we could just put in the number 5 here because we know the length of the two lists, and again, get the same basic behavior. So we don't want to do that, so I'm going to leave it as the original case for I in range len cities, because now if we changed our length of our list of cities and countries, this will automatically adjust and still work properly as it has previously. All right, so we have one more opportunity to check your understanding here. So the question in this case is, what output would the following program produce? So we have odd numbers list, even numbers list, and then a for statement here going through, and we're doing something like adding these numbers together. So take a look at what you have here, look at the loop that we have present, and then go and feel free to visit the polling site where you can fill in your responses to this question. And I'll just put the question up here on the screen. So here are the options for what you would possibly see. And the comma separated values would all be on separate lines. So yeah, fill in your responses and we'll continue in just a moment. What you can see here is that, well, there's very little disagreement here about what this program would produce. Maybe I can make this slightly smaller so we can get all the options visible on the screen. So what output would the program produce? Well, let's go back and just take a quick look at the program again. It was a list of odd numbers and a list of even numbers. For I in range len odd numbers, print odd numbers at position I plus even numbers at position I and show the output there. So what it should be doing is going through, I is going to be defined by our range function, which has the length of odd numbers. So length of odd numbers is going to be 5. So range 5 would give us 0, 1, 2, 3, 4, which would be the indices or index values for each one of these. And we would expect to see that odd numbers first time through at position 0 plus even numbers at position 0 should be taking here 1 plus 10 and giving us 11. Next time through it should then go to index 1. So then it should be 3 plus 4 is 7. 5 plus 6 is 11. 7 plus 8 is 15. And then finally 9 plus 2 is 11. So we expect to have 11, 7, 11, 15, 11. And of course, that does seem to be the most popular choice here because it does seem that you all have understood the basic way in which these for loops are working. There was one syntax error vote here. I'm not sure, but I think in this case, the syntax should be okay. Let's try it out. We can just copy, paste this and run it. And sure enough, we get 11, 7, 11, 15, 11. So no surprises there. There was a question in the chat about why the len function has to be here. So let's take a look at our example. So we have our two lists that we've just defined here. And then we have for I in range len odd numbers. If we take away this len of odd numbers part, if we just had for range odd numbers, the problem is the range function is expecting to receive a numerical value in the call to the function, not a Python list. And I think if we try to run it like this, it's going to complain that there's a type error, that the range function is expecting a number or an integer, to be quite clear, not a Python list. So it's expecting that when you use the range function, what you give it is a number. And I think it may even be the case that it expects a whole number value, an integer, rather than a decimal value. I think you probably could do 5.0. No. So it actually even complains about that. If you try to use the range function with a decimal value, it's like, nope, you have to give me an integer value. So naturally, that is the reason why we can't have just range odd numbers here, but instead we use len odd numbers to get the length. This len function is always going to return an integer value because the length of a Python list can't be a decimal value. It always has to be a whole number. So the length function gives us the number here. Then the range function takes and makes a list of numbers that is that many values long, starting at 0 and ending at whatever the length of the list is, -1. Now, perhaps you're wondering, well, if we have a list to begin with and a list that gets returned, why do we even need to bother with this range function at all? Why not just for I in odd numbers? In terms of the syntax, this actually will work. For I in odd numbers, you can do things with that. Now, the code won't work. It's going to bail out here at a certain point. But this starts out in a way that it appears to work when you do for I in odd numbers, because if you write things in this format, what it does is it says, okay, this is a collection, and I'm going to iterate through the collection. So in odd numbers, the first value there is going to be equal to 1. That value of 1 is actually perfectly fine to be an index value to be used in this list calculation that we're doing here. Odd numbers is equal to 1, so the first time through, what's going to happen is we're going to print the value at index 1 of odd numbers, which is going to be 3, plus the value at index 1 of even numbers, which is going to be 4, and that's how we get the 7 written to the screen here. Second time through, we actually coincidentally also get a perfectly usable value here, number 3, as an index for the values inside this list, because index 3 will refer to the thing in the 4th position of these two lists. So again, we go through and we take 7 plus 8 and we get 15. The problem comes the next time through that it goes and tries to use the third value from here, which is 5, which is outside of the range of index values for this Python list. This would actually be referring to the 6th item in the list when there's only 5. And that's the reason that you get an index error in this case. So there are situations like we saw at the beginning of the lesson where you directly iterate through the values in your list. But if you're trying to use two lists together to access items that are sort of like stepping through each value in your set of lists and doing something with them, the way to do that is to do this range len of odd numbers. And in that way, you'll be able to then combine the values from the two lists and get the output like what we see here. Okay, so hopefully that clarifies a bit. Yep, okay, great. That's good to see. That is sort of it for the for loops part of the lesson. We will continue with conditional statements, but I think we will take a break first. However, I just want to see, are there any questions at this point about for loops before we move to our next topic for the second half? So I'm not seeing anything right away in the Zoom chat. If there are questions that come to mind in the next, let's take a maybe 10-minute break so we can continue about a minute, 10:41 or something like that. 10 minutes from now, we will continue. And if there are questions that come to mind between now and then, you can feel free to add them to the Zoom chat and we will discuss those before moving on. Otherwise, I'll see you in 10 minutes.